Hello friends, Nagraj here and welcome you all for this course of learning, design and analysis of algorithms problems. So in this session I am going to start with the first experiment, that is sort a given set of elements using the quicksort method and determine the time required to sort the elements. Then repeat the experiment for different values of n. So here let me begin with the problem definition and then understand what is there in the problem definition, then code for it. So here I'm going to write the problem definition, that is experiment number 1. Sort a given set of elements using the quicksort method and determine the time required to sort the elements, then repeat the experiment for different values of n. This is our problem definition. We have to, that is, this problem is based on sorting technique. We heard that what is sorting and we learned what is quicksort in theoretical sessions. So here in this session I'm going to explain you about this problem definition and how to code for this using C program. So here the problem definition says that sort a given set of elements using the quicksort method. We are sorting the elements of an array with the help of quicksort method, that is quicksort technique, and that is of type divide and conquer technique. And also we are determining the time required to sort the elements. We are also determining how much time is required to sort those elements of the given array. And also it is saying that repeat the experiment for different values of n. We have to check for the different values of n for different arrays. Okay, let me begin with, let me brief you about first what is quicksort, right? I hope everyone know what is sorting. So we are making use of quicksort here for sorting the elements. That is, sorting is nothing but arranging the elements in an ascending or descending order. But we are having here a divide and conquer technique, that is quicksort method for sorting the elements. So then what is the quicksort and what is the idea behind this quicksort? So the idea is behind this quicksort is, so let me consider one example here, that is, so I have considered here one example, that is a set of students in a classroom. So there are two possible ways of these students to be in a sorted order, that is to be they are in a ascending order or in descending order. Either a teacher may tell that settle them in an ascending order or in descending order, or the one more way is students themselves may come to know that where is their place, that in a classroom a person, or I am the student, if you consider I am a student, I'll be coming to know that where is my position. So based on that the student will find their positions themselves, and who is the very smallest guy, that guy will go to the first and he'll be standing at the first, and who is the last person, and that person will go, who is the tallest person, who will go and stand at the last. This is how the sorting or settling them in an ascending order or descending order takes place. So this is what the idea behind quicksort. That is what I'm trying to say here. The students will be finding their positions themselves in a classroom depending on their height. Depending on their height, they'll be finding their positions in a classroom. So that is the idea behind this quicksort. That is, this is the smallest person here. This is the smallest person here. That who is the smallest person? This one. This person is the smallest person, so he'll come and he'll be standing here at the first, right? Then who is the tallest among this? This is the this one is the tallest person. He'll be coming and standing at the last, right? He's the tallest person. He'll go and stand at the last by himself. By seeing all the students, he'll come to know that where is my position. So he'll go and stand at the last position, and all other remaining people will be getting their positions, will be communicating each other, and they'll be finding their location, their position in the list. That is, this person may communicate with this one, right? And your height is so and so, you go and stand there. My height is this, I'll come here, and again he may communicate with this person. My height is this, you go and go front, I'll go back, and you go back, I'll go front करके all the remaining students will get their position. So this is the idea behind the quicksort method, right? So I'll take another example here. That is, I'll consider some examples here. So I have a list here, that is 10, then 80, then 90, then 60, then 30, then 20. And by seeing this, which element is already in a sorted position, if you look at one glance, which is the element which is at sorted order, or it is at the sorted position. So I'll go with here this value 10, this value 10, this 10. This value is at the sorted position. Why? Because all the elements, all the remaining elements are greater than 10. So all these elements are there in the right side, and there is no element which is smaller than 10. So if it is there, it will be there in the left side. So by looking at this list, we can say that 10 is in the sorted position. And I'll take one more example here. That is, so I'll be taking one more example, 6, 3, 5, then 4, 2, 1, then 9. Then by looking at this list, which is the sorted element among this? By looking at one glance, I can say that directly this 9 is in the sorted order, right? This 9 is already in the sorted order because all the elements which are there here, these all the elements are smaller than 9. So after sorting, the last element will be 9 itself, so it is already in the sorted order. Then one more example I would like to take here, that is 4, 6, 7, then 10, then 16, then 12, 13, and 14. So by looking at once, do you think which is the element it is in the sorted order? Can you guess? It is 10. It is 10 here because all the elements which all are there this side are smaller, all the elements which are there this side are greater than this 10. That is the reason this is already in a sorted position. And this is the idea behind quicksort method. First we have to identify a location of the pivotal element, the location of the pivotal element. So we have to set one pivotal element first, and we have to check whether all the elements on left hand side are smaller, all the elements on right hand side are greater. So this is what the idea behind quicksort method. So let me begin with an array example here. So I'll take an example and I'll explain you people. So the example is, just a minute. So I have considered here an example that is an array that is a equal to 10, 16, then 12, then 15, 6, 3, then 9, 5. So this is my array. I have considered this as an example here. So initially index I am taking it as low element, and at the end I'm considering it as this is low, then this is highest element in the list. So there is nothing in this position, so we have to assign, we have to give a limit for this list. So here I am considering it as an infinity. So this is I am considering just to provide a end of the, just to indicate end of the list of this array, end of the list. So I am taking it as infinity. So and also I am setting here pivotal element, pivot, that is pivot, just a minute, pivot equal to pivot equal to 10. Initially pivot equal to, it will be 10. Pivotal element I am setting 10, and I am taking I loop, then j as here highest element. This is my I and j loops. So I have to apply the quicksort method for this quicksort technique for this, for sorting these elements, that is 10, 16, 8, 12, 15, 6, 3, 9, 5, and I am indicating the end of the list by infinity. That is the highest element, that is the highest element, highest index indexed element in the given list and L as the low. So here 5 would equal to 10 and I'm setting it by I, that is initially I equal to 0 and j equal to 9. And what we have to do here is we have to go on comparing this 10 just to find the location of this pivotal element, or the first whatever the this pivotal element is there, that is 10. We have to find the location of that is nothing but the partition. So partition first we have to do, we have to perform the partition on this list, then we have to sort the remaining elements. Partition is nothing but we are finding the location of the pivotal element, that is pivot equal to 10, that we are finding, and all the elements to the pivotal element left side should be smaller and all the elements on the right hand side should be greater, in such a way that we have to partition. So with the help of pivotal element we are do so. So we have to go on comparing with this 10, this I equal to 10, I equal to 10 is there, so we have to identify which is the element less than 10. And one more for loop we are maintaining, that is jth loop, which is the element which is greater than j. So if so we have to swap them each other. So here 10 is there, so 10 is greater than 16, so it is not less than. So change this, I will come here, I will come here, then 16 is less than 10, no, it is greater than. And this 5, j loop will come here, j will come here, this 5 is less than 16, so swap them each other. So 5 will come here, 5 will come here, 16 will go here. So I'll maintain here one more new list, something it looks like this. So here 60 10 is there, then 5 will come here, 5 will come here, then 8 is there here, then 12, then 15, then 15, then 6, then 3, then we have 9, then we have 5, already 5 is swapped there, so 16 will come here, 16 will come here, because this I is 16, j is 5, so it is smaller than I is smaller than, sorry, I is j is smaller than I, so that we have to swap just to find the position of the pivotal element in the list. That is the reason we are making this partition. So based on the pivotal element we are making the partition on this list, on this array list. So 16 will come here at the end, the highest element, that is boundary of this list is infinity, that is h, and this is L. So again I is here, increment it, I will come here, I will come to this one, then j will come here, j will come here. So here 8 is less than 10, 8 is less than 10, right? 8 is less than 10, that is nothing but, So I have changed here little bit, that is sorted array list. So I'll be writing here only sorted elements. So here, if you are go on comparing this I to J, and if an element is smaller than I, if element is smaller, if element is smaller than I, then J and I will get swapped. So J loop can stop at most I ith location, that is pivotal element, and I for loop can sort or swap till the highest element. So at the end of the list, so here I swapped this 16 and 5, that is 5 is smaller than 16, so swap that. 5 will come here, right? First location 5 will come here, 5 will come here, then 16 come here, 16. So then increment I at this location 8. So 8 is smaller than 10, so we have to identify I should be, that I value should be greater than 10. So 12 is greater, 12 is greater, then decrement this J 9, 9 is smaller than 12, so 9 will get, 9 and 12 will get swapped, right? 9 and 12 will get swapped. So 9 will 12 will come here, 12 will come here, then here it is 8, 8, then 9 will come here, 9 will come here, then increment I will come here, I will come here, then J will come here, 3 and 15, 3 is less than 15, so 3 will get swapped here, that is 3 will come here at the 4th index, 15 will go to the 6th index, this is 15. Then increment I, then decrement J, both are pointing to this location, right? Sorry, yes, it will come here, then 6. So now I is here, that is after incrementing I will come here, then J is here, that is, what is the value here? 6. So now don't interchange this 15 and 6, because this 6 is smaller than pivotal element, so we have to swap that with 10, that is pivotal element, that is nothing but 10 will come here, 10 will come here, then 6 will be here. Now this 10 is in the sorted position, that is all the elements which are there this side are smaller, all the elements which are there at the right side are larger than this 10, that is pivotal element. This is what the partition of the given list. So this is how the procedure takes place for sorting the elements with the help of quicksort method. So let me code for this and show you that how exactly this works for solving the problem or for sorting the elements using quicksort method. So let me clear this all here, then we'll move for coding, that is So in the program for coding, we are here making use of hash include stdio.h as an header file, because we are performing some basic standard input output operation in this program. We have to have this stdio.h header file, and one more header file we are making use of, that is hash include time.h time.h, that is for finding or for determining the time required to sort the elements. So we are making use of that header file, standard library file, and also just uh, to indicate the limit of the, or we are creating here a constant, that is max is 500. That is, we are creating a constant here for an array list, that is, that indicates the limit for list. So, and one more constant we are creating for clock ticks or 100. This is the maximum value of the clock ticks required to the sorting the elements of an array using quicksort. So here we are making use of these two constants in our program. So let me write the code here. For first, I am declaring two more methods, that is void, then quicksort, and it will be taking arguments as int array, then int. These are the three variables we are passing, like integer and array, then low, then high, as the low and high element of the given array. Then one more method, that is int partition, and it will be taking again three variables, that is int, same variables, same number of arguments we are passing for this also. So it will be having here and name of the array, then low, then high as an elements. Then in the main method, int a of max, that is maximum 500, and I for loop, I is for used for loop, n is for size of the array, then clock t for s comma e. Then we have a printf statement here, just to ask a user to enter the size of the array. Enter the size of an array then scanf, how to read the size of an array with the help of scanf statement. So scanf %d, then comma ampersand n. This statement will read the location of that value n. Then printf, ask the user to enter the elements of the array. Printf, then enter the elements. So /n. Then how to read those, right? With the help of for loop. For I equal to 0, then I less than n, then I plus plus, then scanf. Because n number we are reading, we have to use the for loop. Scanf %d comma ampersand i a of I. These many elements we are going to read, and every time we are going to read ith element. It may be 0, it may be 1, it may be till n, from 0 to n elements we are reading with the help of this printf and with the help of this scanf statement. Then after getting after getting all the elements, we have to sort that. So for that reason, I'm going to call this quicksort method that I have declared here. The body later I'll be writing, but here after getting the elements, I have to sort. My array is a, then 0 is the lowest element, that is lowest element, then n minus 1 is the highest element, because we are starting from 0th index, so we are considering it as n minus 1. So after sorting, we have to print the right of sorting, we have to print the element. So printf elements after sorting, elements after sorting are as follows. Then how to print after sorting? We have to make use of for loop again. So for I equal to 0, then I less than n, then I plus plus. These many elements we have to print again with the help of printf statement, again with the help of printf, then %d, then what we have, %d, %d here, then we have comma a of I, that is a of I. Then after that, we have to check the time required to sort those elements, right? So I have to print that time also. So printf then /n time required to sort the elements, So what we have to do here is, definitely it will be a double value, then e minus s, then divided by clocks per sec. This is the standard unit of the system time, that is clocks per sec, for identifying the time required to sort element. Then we have I have to write here quicksort method. So void the body of the quicksort method, right? Quicksort, then we are passing int a, then int low for the lowest element, then int high for the highest element of the list. Then under this int j Then if what I explained in the example, that is if low equal to, if low less than high, if low less than high, what we have to do here is we have to perform j equal to partition, j equal to partition. Then what are the arguments of partition method that I have declared before this main method, that is partition an array we have to pass a, then low as the lowest element, then high for the highest element of the list. Then after performing this, so let me write what is the partition method does. So after sorting this, after completing this quick sort, I'll be writing this partition. So we are calling that partition method here. What it will be doing, I have explained already. So here again call this quick sort method, quick sort, quick sort, then a comma low comma j minus 1. This is swapping, right? Then not swapping, it will be taking the lowest element array and j minus element, that is j minus 1 element. Then one more time quick sort, that is quick sort, quick sort a comma j plus 1, j plus 1 comma high. Till here it should sort. That means it will be sorting all the elements after partitioning. It will be solving all the elements which are there at the left side of the pivotal element, all the elements which are there at the right side of the pivotal element. So this is what the quick sort method will be doing here. Then we have one more method, that is partition. int partition we have to pass here a, that is pivotal element, int a, right, int a comma int low, int high. Then we have here, we have to write the code for partition. So first what we did, int pivot, right, int pivot comma I comma j, pivotal element pivot, then j loop, I loop, and one temporary variable for swapping purpose. So temp, these many variables I'm considering here for swapping of the list. Pivot equal to a of low, a of low, then I equal to, initially I equal to low plus 1, because I will be the initially I will be at the pivotal element, that we have to increment, that is the reason low plus 1. Then j equal to high, j equal to high. Then while 1, then till here, till while become 1, what we have to do, again we are making use of while. If pivot, while pivot greater than a of I, greater than a of I, and I less than or equal to high, I less than or equal to high, do this. What we have to do? Increment I, that is I plus plus. Then we have to decrement j, right? We have to decrement j also. Then while after comparing with each element, we have to increment I and we have to decrement j. So that is the reason I am making use of these for loops, these while loops. So while pivot less than a of j, less than a of j, then j minus minus, that is j minus minus. Then if I less than j, if I less than j, what do we have to do? We have to swap, right? If I less than j, we have to swap. Then for that I'm making use of this temp variable, temp equal to a of I. Then a of I will become a of I will become a of j, a of j. Then a of j will become a of j will become temp. Whatever is there in temp, it will be coming here, because in temp we are having a of I. So this is our if statement. Then else, otherwise if I not less than j, then what it should do, right? In that case it has to perform, that is the swapping of, the swapping takes place here also. Temp equal to temp equal to a of I, sorry, a of j. Then a of j equal to a of j equal to a of low. Then a of low equal to a of low is equal to 10. Then after doing this, return j value. This is how this quick sort technique is used for sorting the elements of the given array or elements of the given list. So let me run this code and check whether it gives the proper output or not. So click on run button here. In function partition, error expected equal to attribute before. Okay, click on the line number 26. What it is saying, where it is, this one, int main bracket. So what is missing here? So we are missing here one semicolon, right? So click on run button once again. Oh, that's great. Enter the size of an array. So I'll enter 5 elements. Size of my array is 5. Then enter the elements. So same elements I'll be entering, that is what is that, 10, 16, 18, right? 10. So run and check it. So array size is 5. Hit the button enter, then enter the elements. What I'll do, 10, then 16, then 8, then 12, then 15, then 6, 3, 9 and 5. So what are the elements here? How many elements are there? Only 5 are there. 1, 10, 2 3 4 5. So remove this. Okay, this is my array. So just hit the button enter, then after sorting enter the elements 10 16 8 12 15. That is, first element will be 8, then 10, then 12 15 16. So it is displaying here all the elements without white spaces. So what I'll do, I'll make use of this slash n, or else slash t. I'll use slash t. So rerun it once again. Then size is 5. Then what I'll do, 10 15 8 12, then 6, then hit the button enter. 6 8 10 12 15, and the time required to sort elements is nothing. So there is something mistake, right? I think, just a minute, just a minute. Okay, here we are not specifying that the percentage f, the type of the value. So that is the reason it is displaying there 0. So right there, percentage f, that is type float. So click on run button, then check it once again. Enter the size of the array is 5, enter the element of the array 10, then 12, then 15, then 8, then 20, 20. So hit the button enter. Yes, we got it. 8 10 12 15 20. It is in the sorted order, and the time required to sort these elements is this. Right, it's working properly. If you are having any doubts in this, please do ask your queries, and definitely I'll be helping you out for your queries. And thanks for watching.